Today I will discuss about the naming of the mononuclear coordination compound. Before going the naming of the complex compound, I will discuss some important terms which is used in a coordination compound. For example, a K4FeCN whole 6 coordination close. This is the example of the complex compound. Okay. In this complex compound, this square bracket indicates coordination entity. This coordination sphere indicates what? Coordination entity. And there are three different types of coordination entities. First one is a positively charged coordination entity. Next is a neutral coordination entity. There is no charge on the coordination sphere or coordination entity. And third one is a negatively charged coordination sphere. Okay? Inside the coordination sphere, there are central metal ion. Usually, central metal ions are atoms belong to the D and F block element. With the central metal ion, some donor species are attached, known as ligands. Ligands may be negatively charged, neutral, or positively charged. And the number usually indicates, this number indicates the coordination number of the complex compound. And with the help of this coordination number, we can also find the geometry of the complex compound. For example, there is a 6 coordination number in this example. It means the molecular geometry of the compound is octahedral. And the hybrid state sp3d2 or d2sp3, so especially this is the d2sp2. And coordination sphere or coordination entity is non-ionizable in nature. Okay? And outside the coordination sphere, either this side or this side, which is ionizable in nature, and this is known as counter ion. It means outside the coordination sphere, there is a presence of counter ion. Either it is positively charged counter ion or negatively charged. For example, in this case, Cu NH3 whole 4 coordination close SO4. In this case, the counter ion is sulfate ion, but in first case, the counter ion is K plus ion. And number of the counter ion in first case, there are 4 moles of K plus ion. In the second case, there is only 1 mole of the sulfate ion. These are the basic terms which is used in a complex compound. Okay, class? And for the naming of the mononuclear coordination compound, especially in the ionic complex, the order of naming is cation name first, then ligands are arranged in an alphabetical order, then central metal atom or central metal ion, and then write the oxidation state of the central metal in Roman within a bracket and followed by anion. That is the important thing for the naming. So first of all, how to write the name of the ligands. If For the anionic ligands ending with the ite, and ate, the suffix e is replaced by the o. For example, especially if the suffix is I, de, I, te, R8, then in each case suffix e is replaced by o, that is IDO. In second case again e replaced by the o, that is ITO, and in third case e is again replaced by the o, that is ATO. By taking some example, first chloride, the E replaced by the O, that is the chlorido. Similarly, next example, amide, that is NH2 single minus, again E is replaced by the O, and as a name of ligand, that is amido. And next, carbonate, the E replaced by the O, and as a name of ligand is carbonato. But especially in case of ambidentate ligands, it is the type of monodentate ligand, but the mode of linkage are different. For example, NO2 minus, and suppose M is the central metal and it is linked with the NO group, nitrogen donor atom, and in the second case it is linked with the oxygen as a donor atom. It means this is the type of ambidentate ligand. Especially in case of ambidentate ligand, during the naming, the linking atom must be indicated like this is the ONO, nitrito dash O. This O indicates the donor atom of the ligands which is attached with the central metal atom or ion. In second case, that is N double bond O negative, the nitrogen is the donor atom, therefore as a ligand's name nitrito N. It means O and N indicates the donating sites of the ambidentate ligand which is attached with the central metal. Clear, class? Next type of ligands, that is the neutral ligands. Neutral ligands means there is no charge but having a lone pair electron. Especially in this name as a molecule like C6H5N, that is the pyridine, and abbreviated form is PY. So name as a ligand is pyridine, that is C5H5N. And next example is H2N CSNH2, that is the thiourea. It is also behaves as a neutral ligand. And next is important neutral ligand, that is NH2 CH2 CH2 NH2, and this is the ethane 1,2 diamine, and abbreviated form is EN. So these are the neutral ligands which name as a molecule. But next type of neutral ligands not named as a molecule. like H2O as a ligand's name aqua, AQUA. Next, NH3 amine, that is AMMINA. NO nitrosyl, similarly CO group carbonyl. So these are the neutral ligands but not named as a molecules like H2O, aqua, NH3, amine, NO, nitrosyl. Okay, and next type of ligands, that is the positively charged ligands. And there are very few examples of the positively charged ligands. And first, NO2 positive, that is the nitronium ion. So especially in case of positively charged ligands, the suffix IUM is used in the name of the ligands, like NO2, nitronium. And next example is NH2, NH3 positive, that is the hydrazinium ion. Okay, so especially during the naming of the ligands, first of all, if more than one types of ligands are present, then you must arrange these ligands in an alphabetical order. Okay, and after that, you must indicate the number of the ligands, that is the numerical prefixes to indicates the number of the ligands. It means if more than one type of ligand, similar ligands are present, then you must indicate the number of ligands, and as a prefix for two similar ligands, the term is used, the prefix is used, that is the di. And if three similar ligands are present, then you must use the prefix, that is the tri, tetra, penta, and hexa. It means these prefixes are used to indicate the number of ligands present in the complex compound. Okay, but if the prefix di, tri, tetra are used in the name of the ligands, then to avoid the confusion, the number of ligands, if two similar ligands are used, then the term is used, that is bis. And if three similar ligands are present, then the term used, that is the tris. And similarly, tetrakis, pentakis, and hexakis. Especially in case of if the prefix di, tri, tetra are used in the name of the ligands, then for two similar ligands, the prefix used, that is bis, tris, tetrakis, and pentakis. Clear? And next step is the naming of the center metal ion. You must first of all decide the types of coordination entity. Means either it is positively charged coordination entity, neutral, or negatively charged. Especially in case of positively and neutral types of coordination sphere, the simple name of the center metal is used. Like if as a Fe center metal, then simply write their name iron. Suppose Co is present, then write their name cobalt. But in case of the negatively charged coordination entity, the suffix 8 is used at the naming of the center metal atom. For example, like PB, plumbate, it means at the end of the name there is ATE. Next example, Fa, ferrate, FERRATE, zinc, zincate, and cobalt, cobaltate. So especially you must care in the naming of the complex having a negative charge, means a negatively charged. The suffix ate must be used during the name of the central metal ion. Okay, and after the naming of the central metal ion, you must write the oxidation state of the central metal ion within bracket in a Roman, and at the end, if there is a presence of anion, then write the name of the anion. So the simple sequence, again you must write the complex name in this sequence, cation name first if it is present, then ligand's name, then central metal, ion or atom, and then oxidation state of the central metal, and at the end there is a anion. For example, CO NH3 whole 4 coordination close SO4. How to write the name of this complex compound? Okay, according to these rules, first of all, there is no cationic counter ion. Okay, it means first we will write the name of the ligands, and how many ligands are present here? There are 4 ligands. It means as a suffix tetra, and as a ligand is amine, that is AMME, amine, tetraamine, and the central metal is copper, and then write the oxidation state of the central metal within bracket, and the central metal oxidation state is +2. It means in a Roman that is 2, bracket close, and at the last there is the name of the anion, that is sulfate. It means the name of this complex is tetraamine copper second sulfate. Okay, and before the naming of one more example, there is some basic points you must know about the naming of the complex compound. First, name of the complex compound should not start with the capital letter. Always start with the small letter. Okay, first thing. And second thing, during the naming of the complex ion, there is a one single sentence is used as a naming, and if there is a counter ion, then there is a space between the counter ion and name of the coordination entity. So there is some basic points during the naming of the complex compound. And next example is K4 Fe Cn whole 6. Okay, and the counter ion is as a cation. It means cation name first, and this is potassium, and number of the ligands 6 as a suffix hexa, and as a ligand is cyanido, and central metal is Fe. Because this coordination sphere is negatively charged, Therefore, as a suffix for Fe, we must use ferrate, that is Fe-R-R-A-T, and then write the oxidation state of the center metal within a bracket, that is the second within bracket. The name of the complex compound is potassium hexacyanidoferrate second. Next example, FeCO whole 5 coordination close. This is the type of neutral coordination entity. Okay, and ligand is CO, that is the carbonyl, and the number of ligands are 5. So this is pentacarbonyl. And what is the oxidation state of the center metal atom? It is a neutral. Okay, and the oxidation state of the center metal is 0. Then write their oxidation state within bracket. Okay, so pentacarbonyl iron, and then write their oxidation state, that is the 0, and the name of this complex compound is pentacarbonyl iron 0. Next example, that is NiCO whole 4. Okay, again this is a type of neutral coordination entity, and this is the tetracarbonyl nickel 0. So these are the some examples of the complex compound and how to write the name. Okay class.